we've got here the traveling salesman problem. And what I'm going to do is I'm going to start off in Madrid. So let's just make Madrid here my starting point. And I want to visit every single town here in Spain, which I've produced from this adjacency table, but using the minimum connection. And I want to get back to Madrid at the end. So I need to use the traveling salesman problem. But what I'm going to do is I'm going to break this up into a number of things. So I'm going to do, first of all, the upper bound for the traveling salesman problem. Then I'm going to refine that using the nearest neighbor algorithm. And then I'm going to take away one of the vertices. So I'm going to do a vertex deletion to improve upon my nearest neighbor. But first of all, the upper bound. Now, the upper bound is to find the minimum spanning tree of this network. Now, I don't need to start in Madrid for the nearest, for the minimum spanning tree. I'm going to use Kruskal's algorithm. I'm going to find the shortest edge, which is right here, Seville to Cordoba, 150. Then the next shortest edge, 160. The next shortest edge is 200, but 200 will produce a loop. So I'm not going to use the 200. So looking around, I've got a 350 here. And after 350, I've got a 360 here. I've got a 400 here. So still no loops. I'm not going to use 570 because that would actually produce a loop. I've got Madrid to Malaga, which I forgot to put in there. So let's have a look. Madrid to Malaga is 530. And anyway, I don't want to use this 530 because that would make a loop. So the only one not connected at the moment is Vigo. And so I can probably just get straight in there and look at this one as 610. Like this. Let's make that a bit better. So I'm going to go from Vigo up there in the north of Spain down to Madrid. Now all the cities are connected and they make a tree with... So now it's just a question of adding together all of those numbers. So do this one on my calculator. I've got 610, 360, 350, 400, 160 and a 150. So that gives me 2030. And I'm going to times that one by 2 once I found the minimum spanning tree to give me 4060. And this is the upper bound of the traveling salesman problem. And what I was actually saying is I can visit every single town once and come back to where I started. So I could go along from here to here and then come back. So I'm doubling the minimum spanning tree and then down and down and then back and so on. So every single journey that I make, I count twice. So this is basically saying this is the most we need to use. Now, clearly we can do better than that because rather than going out to Madrid via Valencia, we could then just go along this line back. But we're not trying to refine it yet. This is just the upper bound. So that's the minimum spanning tree, Kruskal's algorithm, times by 2. Now in the next video, we're going to do the nearest neighbor problem.